Yo, this is Mr. O. Yo, this is Mr. O. And today we're going to learn about arcs and angles formed by intersecting chords by secant and tangent. Before anything else, what is tangent? Tangent is when a line or a portion of a line intersect or touch the circle at exactly one point. While secant, when a line or a portion of a line cross the circle through 2 points. Okay, that's the difference between secant and tangent. So let's go ahead now and look at this figure here. So I have here two chords or two lines that could possibly cross the circle, and their intersection is inside the circle. While on the figure number 2, I have a secant here and I have a tangent here, and they cross on the circle. And there's also a possibility that two secant lines intersect and they cross outside the circle. It's really important that we understand the situation of the figure so we can apply the formula correctly. So let's go ahead now. So if two secant or chords intersect inside a circle, so this is the intersection, then the measure of the angle formed is equal to the half the sum of the measure of the intercepted arc. Means, say, if this is my figure, so this are my two secant, the intersections right here. They form an angle here. This angle 1, right? The angle 1, for me to determine angle 1, I need to add or get the sum of arc AD and BC and then divided by 2. So the formula for angle 1 is half of the measurement of arc AD plus the measurement of arc BC. Take note, I'm only using the arc that is basically opposite, or the arc being formed by angle 1. And likewise with angle 2, if this is my angle 2, it's going to be half of this arc and that arc there if you get their sum. So it will be half of the measurement of arc AB plus the measurement of arc CD. Okay, let's look at this example here. Find the measurement of angle AED. AED. So I'm looking for this angle here. And the arcs are 45 and 109. Okay, so applying the formula here, the measurement of angle AD is half of the measurement of arc AD, which is 45, plus the measurement of arc BC, which is 109. So 45 okay, hold on. $45 plus 109, enter, times half or divide by 2. The answer is 77. Kaboom. Find the measurement of angle STR. STR is right here. So same thing. The angles opposite to STR is 112, and on its back on the other side is 186. So applying the formula, half of the arcs, measurement arcs, 112 and 186. So 112 plus 186 divided by 2 will give me 149 degrees for angle STR. Okay, that's 149. Now, what if we're looking for arc LK? This is arc LK here. But the angle formed by the two secant is given to be 62. Okay. Remember that when we add the two arcs. So when we add the two arcs, this is x, right? X plus 74. And we multiply by half. The answer must be 62. So how are we going to solve for the x there? We're going to multiply everything here by 2 and by 2 here to cancel the 1 half and the 2 there. So that will give us x plus 74. 62 times 2 will be 124. Minus 74 there, minus 74 here. That will give us x equal to 124 minus 74 is 50. So the arc LK is 50. Easy, right? Next, I have here measurement of arc CDE. That's what we're looking for. CDE is right here, this one here. And we know the angle that formed by two secant is 128, and this one here is 73. So, so I'm gonna add the x and the 73 multiplied by half. The answer must be 128. So again, we are multiplying everything here by 2 and by 2. So this cancel out x plus 73. 128 times 2 is 256. Subtracted by 73. The answer is 183. Kaboom. All right. What about if we have a secant and a tangent intersect at a point of tangency, or point of tangency is where the tangent line and circle touch. Then the measure of each angle formed is equal to the half measure of the intercepted arc. So if this angle 1, the intercepted arc will be the red one here. Okay, that's the intercepted arc, but the angle 1 is right there. Okay, so what's the formula here? Formula is angle 1 is half of the measurement of arc AB. So basically, you're just gonna cut the red one into half and it will give you the angle. Same thing with angle 2 here. If this is the angle 2, the red one, I am going to cut this to half, the BCA, that arc there. So half of the measurement of arc BCA. Okay, so look at this example here. Measurement DEG. DEG is this angle here, and the arc, the intercepted arc is this portion here, okay, which is 308. Okay, so what's the formula? Half of the measurement of here is DHG. That's not D. I'm wrong. E or EHG. Okay, that will give you the angle DEG. So half of 308, which is 308 divided by 2 is 154. Kaboom. Next, find the measurement of DBC. DBC is the one on the back. Okay, but the given intercepted arc here is the 192, which for the other angle. So what do we need to do? We know that the circle has a 360 degrees. So I have to get this portion here. So 360 minus 192, that will give us 168. So this is 168. So now I can get this part by dividing that 168 by 2. Divided by 2, the answer is 84. Next, arc X. This time we're looking for the intercepted arc. XY is this teeny tiny right there, okay? But the angle given, remember this is a straight line here, right? This is straight, the blue is a straight line. This is 151 according to the problem. So if that's 151, how much is this angle here, this purple one? 180 minus 151 will give us 29. That's 29. So in other words, this angle here, purple here, is 29. So how much is this arc here? This red arc. So what do we do here? You know that the formula is half of the measurement of arc XY is equal to 29. That's the angle. So we just multiply it by 2 by 2. that will cancel it out. So the measurement of arc XY is 29 times 2, which will give us 58. Kaboom. Next, what about if we have the exterior intersection? So there are several possibilities here. If secant and or tangent intersect on the exterior of a circle, then the measure of the angle formed is equal to the half the difference of the intercepted arc. What's the meaning of that one? So if you notice first, all of the intersection, whether it's two secant, tangent and secant, or both tangent, all the intersection are outside the circle. Remember that. Next, they form two intercepted arc. One is the big one, which is in this case, say, or larger one. This one is the larger one, and this is a smaller one. In this case here, this is the larger one, and this is a smaller one. And here you have, this is the larger one and this is a smaller one. Okay, what you normally do, what you just have to do here is subtract the larger arc minus the smaller arc, then divide by 2 or times by half. Okay, that's basically the formula. So in this case here, it will be half of the measurement of arc CE minus the measurement of arc BD. For this figure, half of the measurement of arc BD minus the measurement of arc BC. And in this case here, half of the measurement of arc BDC minus the measurement of arc BC. Okay, that's the formula for this figure. Okay, so just subtract the larger by the smaller intercepted arc, then times by half. Okay. All right, let's do this example here. So find KLM. Okay, the measurement of KLM. So we're looking for this angle here. So we know this is the larger intercepted arc. This is a smaller one. So it will be 140 minus 66 times half will give us the angle KLM. Okay, so 140 minus 66. 74 divided by 2 is going to be 37 degrees. Okay, so that is going to be 37. So next, measurement of angle BCD. So this is the larger arc. We do not know this, and we do not know, obviously, the measurement angle BCD, but additional information that this is a diameter. There's diameter, so we know it's 108 degrees. So if this is 67, this is 94, I can get that smaller arc there by subtracting it from 180. So I'm going to add for 67 by 94. That give me 161, and then I can subtract the 180 now. That will give me 19. So the smaller arc is 19. So therefore, I can now find half of 67 minus 19 will give me the measurement of arc, the measurement of angle BCD. 67 minus 19 divided by 2. The answer there is 24 degrees. Okay, easy. Kaboom. Next, now this time we're looking for the arc SW. So we're looking for the angle, the intercepted arc, the larger arc there. Okay, I know the smaller one and I know the angle SUW. So we know the formula is half of the larger one, which is, let's say, the X, minus the smaller one, 75. The answer there will be the angle measurement, right? So again, we're going to multiply here by 2 here. This will cancel out. So X minus 75 is equal to 80. Add 75 on both sides. That will give us X equal to 155 degrees. So this is 155 degrees. Okay, easy, right? Next, measurement of KLM. So we're looking for the angle here. And again, this time we have the larger angle right here. And this is a smaller angle, okay? A smaller arc. That's a larger arc and smaller arc. So it's going to be half of 135 minus 33 is equal to the angle. So 135 minus 33, 102 divided by 2 is obviously 51 degrees, okay? Next, and this time we have a tangent and a secant. I know that this is the smaller arc. I have to get that one there. But remember, the entire circle is 360. If I have a 62 here, I have an 88 here already, I can get this portion by subtracting 88 and 62 from 180 after you add them. So 360 minus 88 minus 62, excuse me, that will be 210. Now I can find the angle ABC because I have the larger arc and the smaller intercepted arc. So half of 210 minus 62 is equal to 210 minus 62 divided by 2 is 74 degrees. Kaboom. Next, I have here the larger intercepted arc, and I do not have the smaller or shorter intercepted arc, so that's my x, but I have the angle 77. So therefore, I'm going to have half of the larger arc, which is 191, minus x is equal to 77. Same thing, I'm going to multiply it by 2 here. This cancel out. 191 minus x equal to 77 times 2 is 154. So I will subtract 191 here, subtract 191 there, minus 191 will give me negative 37. Negative x equal to negative 37. So therefore, x equal to 37. Okay. And last set of example here, the measurement of PQR. I do not know the angle. I do not know the smaller arc. I only know the largest arc there. Okay. Very simple here. Okay. So you know that the we have two tangent. So for me to get that one, the entire circle is 360. So 360 minus 313 first, that's going to be 47. So that will give me 47 there. So half of 313 minus 47 is equal to, so 313 minus 47 divided by 2. The answer is 133 degrees. Kaboom.